Good day, everyone. I am Franklin L. Vitasolo, and I am going to discuss about the common problems in feeder and silo operations and safety precautions. For the introduction, first, what is a silo? A silo is a tall cylindrical facility used to store bulk materials like grains, cement, coal, and other raw products. It protects contents from moisture, pests, and contamination while allowing controlled flow into feeders and processing equipment. In the Philippines, silos are crucial for food security and industry, especially for rice and corn storage. This presentation will highlight common operational problems and the safety measures needed to prevent accidents and maintain quality. What are the different types of silos? The first type of silo is the tower silos or the vertical silos. Tower silos are tall cylindrical structures usually made of concrete, steel, or fiberglass that store bulk materials like grains, silage, cement, or powders using gravity for flow. Common in large farms and feed mills for their high capacity, they require regular maintenance to prevent moisture, stress, and compaction that can cause blockages. The second type is what we call bunker silos. Bunker silos are trench-like storage systems with concrete walls and plastic covers, commonly used in medium to large livestock farms for cost-effective silage storage. Proper compaction and sealing are essential to prevent spoilage, molds, and nutrient loss. Figures presented are the examples of tower and bunker silos. The third type of silo is the bag silos. Bag silo are long, sealed plastic tubes laid on the ground and filled with silage or grain, offering low-cost, flexible storage for small-scale farmers. They are ideal for temporary or seasonal use but require proper site selection, inspection, and protection to prevent punctures, UV damage, and pest infestation. The fourth is the horizontal silos. Horizontal silos are cylindrical units laid horizontally, usually made of metal or reinforced plastic, and used in industrial settings to store powders, feed, or cement. They allow easier loading and unloading with conveyor systems, making them ideal for batching plants and manufacturing facilities, though regular cleaning is needed to prevent buildup and contamination. Next is the common problems in feeder and silo operations. First is the flow blockages and rattling. Flow blockage, especially rattling, occurs when material flows through a narrow channel, while the rest remains stagnant, reducing storage capacity and posing safety risk. In humid climates like the Philippines, clumping makes rattling more common, requiring proper silo design, aeration, and flow aids to prevent it. Figure A is the sample of flow blockage and rattling. Next is the bridging or arcing. Bridging happens when material forms a solid arc over the outlet, blocking discharge and rattling production. It is common with moist or irregular particles like rice and corn, and prevention requires vibration systems, flow conditioners, and strict moisture control. Presented in Figure B is the sample of bridging or arcing. Next is segregation of materials. Segregation occurs when particles of varying sizes or densities separate during filling, causing uneven product composition and poor quality. In Philippine feed mills, this can harm animal health and productivity. So proper silo design and blending equipment are essential to reduce the problem. Next is the mechanical wear and feeder malfunctions. Continuous use of screw feeders, conveyors, and discharge gates leads to mechanical wear, causing uneven flow, contamination, and costly downtime in food processing plants. Preventive maintenance, proper design, and timely part replacement are essential to ensure reliable operations. Next is the dust accumulation and explosions. Dust accumulation in silos can create explosive atmospheres, posing severe risk to workers' safety and plant integrity. Preventing this hazard requires proper ventilation, dust collection systems, strict cleaning protocols, and air quality monitoring, especially in tropical conditions where dust stickiness increases the danger. Presented below is the sample picture of dust accumulation and explosions. Next is spoilage and pest infestation. Spoilage and pest infestation are major challenges in silo operations, especially in humid tropical regions like the Philippines, where mold insects, and rodents threaten grain quality and safety. Preventive measures such as aeration, fumigation, moisture monitoring, and compliance with the Philippine National Standard are essential to maintain quality and protect consumers. Photos below are the samples of spoilage and pest infestation. Next, we have a safety precautions. First, the structural integrity and standards. So follow the Philippine National Standard 2019 for silo design and construction. Next is inspect regularly for cracks, corrosion, and deformation. And also avoid overloading and uneven filling. Next safety precaution is dust control and ventilation. Install dust collectors, explosion vents, and air filters. Maintain proper ventilation to prevent pressure buildup. And also enforce cleaning schedules and monitor air quality. Next is the confined space entry protocols. Use harnesses, lifelines, and gas detectors. Follow DOLE confined space entry standards. And also, always have a standby person and emergency equipment. The next safety precaution is the material flow management. Use flow aids like vibrators and air cannons. Maintain proper moisture levels in stored materials. Design hoppers for mass flow to prevent bridging and rattling. Next is the pest and moisture control. Seal silos to prevent entry of pests. Use aeration system and conduct regular fumigation. Monitor temperature and humidity with sensors. Next is the fire and explosion preparedness. Equip facility with extinguishers, alarms, and sprinklers. Use explosion-proof wirings and spark detection systems. Also, conduct fire drills and post-evacuation plans. Next is the training and supervision. Train workers in hard recognition and emergency response. Provide refresher courses and enforce safety protocols. Also, supervise operations to ensure compliance. Next is the monitoring and automation. Install sensors for temperature, humidity, and gas levels. Use automated feeders and alarm systems. And also enable remote monitoring and data logging. So here are the references used in this report or in this discussion. So you can check these references. And thank you for listening. To know more about silo, watch the processes of silo operation. especially for grain silos. The link is provided below.